So number 29 has two very long wires in cross-section that each carry a current of 4 amps directly out of the page. Distance D1 is 6 meters and distance D2 is 4 meters. What's the magnitude of the net magnetic field at point P, which lies on the perpendicular bisector? So how do we solve this one? Well, first of all, we need to figure out the distance here. And if you work it out, the magnetic field, if you do your right-hand rule, should be pointing at this direction. That's perpendicular to that distance that we just drew. The distance, since we know the total distance D1 is 6, that's 3 meters to the bisector, 4 meters out, that's a 3, 4, 5 triangle. So we know our distance, and we can find the magnetic field just using Ampere's law. In this case, we're using a circle going around, centered around that top wire. The current inside is just going to be the current through that wire, and you, of course, get this, mu naught I over 2 pi r. Plugging in the current, which is 4 amps, and the distance, which is 5 meters, we get this. Now the question is, what's the total magnetic field? Well, this bottom wire is going to produce a magnetic field that's pointing up this way, and the exact same length, but going this way. The horizontal components of these two vectors are going to cancel. So really all we need to do is find the vertical component of this magnetic field and then double the results. So doing a little bit of quick plug and chug, if you do a little bit of realizing that these are similar triangles, and this still has to follow the 3, 4, 5 rule, we can realize, oh, wait a second, the magnetic field along this side is just going to be 4/5 of the magnetic field. So we can just take 4/5 times the magnetic field we just found in this previous one to figure out what the magnetic field along this vertical component is. Plugging that in, here's our 4/5 again, times the answer we have above, and multiplying that out, we get 16 mu naught over 10 pi. The total magnetic field, or we can reduce it down, sorry to that, the total magnetic field is going to be double that, because remember we have a vertical component from both of them. So doubling that and plugging in our numbers, we'll get the magnetic field is about 1.28 times 10 to the minus 6 teslas. And that is our final answer. Good luck.